Hey, good morning everyone and welcome to our channel Learn Data Science with Randall. So this is video number 4 in time series modeling. So in my first video we have discussed the patterns in time series. In second video we have discussed what is stationarity. In the previous third video we have discussed how to see the stationarity in our Jupyter notebook in Python, and then how to make the data stationary if the data is not stationary. So slowly we are moving towards the model building. So over here there are different patterns. I'll not say pattern, but there are different models which can be created in a time series model. So I have already written the names of the models which we can create. So for example, let's say you are doing supervised learning, so you may choose some model. Similarly, in time series modeling you have to decide which model you are going to use, and these are the names of the model. So the first model is my AR model, that is your auto-regressive. MA is your moving average. Third is ARMA, auto-regressive moving average. And then we have our ARIMA, that is our seasonal auto-regressive integrated moving average. And then we have SARIMAX, seasonal auto-regressive integrated moving average. And X over here stands for your exogenous. Exogenous as in external factors. So for example, let's say there is let's say you have a restaurant or you have a shopping mall and you want to find out the number of people visiting your shopping mall. So number of people visiting a shopping mall may also depend upon how many may also depend upon a holiday, and holiday doesn't comes in any pattern, so it's an external factor. You may have 10 holidays together and then you may not have any holiday. Over here I am not counting Saturday Sunday as a holiday. So Saturday Sunday can be automatically taken care of by time series model because they come in a periodic. So every 7 day it would be a Sunday. But let's say suddenly there is a holiday on Wednesday or on Tuesday, then the numbers may increase. So those things have to be taken care by external factor, that is your exogenous factor. So SARIMAX is the highest version or the highest level of the model building. So earlier we used to decide which type of model we need to create, but with advance in the libraries, so the current libraries automatically decide for us that which model would be best for us, and the model is created, the best model is created. But as a good data scientist, we should understand what are the parameters which are being used in the model. So, and before that, I have written something. So in the next slide, I am going to discuss what is our AR model, what is our MA model, and everything. But keep just read this sentence. So I have taken an example. Let's say today's 30. So basically, I have taken an example, and the same example I would be using in all the other would be using in my all the different models, whether it is AR model, MA model, ARMA. So I'm saying, let's say today is 30th June and company wants to do the forecast of the sales for the July month. So why I'm taking 30th June is so that people don't get confused. So if it is 30th June, the company would be knowing the actual numbers of my June month. Okay. So in real life, probably the company might have done the forecast for the July month before 30th June as well. But in this example, I am assuming, let's say today is 30th June. So if we are building an AR model, so AR model uses the past actual terms or the values. So in our AR model, that is our auto-regressive model, this would be your equation. Yt is equal to C plus phi1 Yt minus 1 plus phi2 Yt minus 2 plus phi3 Yt minus 3, and this goes on till your phi n Yt minus n, and this the last thing is your error term. Over here in the example, if you notice, if you remember, then I have said that I want to do the forecast for my July month. So Yt is the forecasted value for the July month. C is a constant. If you see this equation is almost similar as your linear equation. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus till your beta and xn. So same thing. Over here, phi 1 is a kind of your slope. And what is your Yt minus 1? Yt minus 1 are the actual values for your June month. Why? Because we are doing the forecast for the July month. Yt minus 2 is the actual values for your May month, and Yt minus 3 would be actual values for your April month. So if I want to do the forecast for July month, the June month would be the most important, followed by the May month and April month, so on and so forth. So remember one thing, we always need to keep one thing in mind, that in time series modeling, we cannot break the sequence of the timing. So if YT, for YT minus 1 would be most important. So for month N, the just previous month would be the most important. So for August, July would be most important, and for July, your June would be most important. So this is the equation in your AR model. In our next video, we will see how to find the values of phi1, phi2, and how are the values of phi1, phi2 found, and what and then how many variables to be used in equation. Should I use should my equation use till phi1 yt minus 1? Should I go through previous 3 time intervals or previous 4 time interval? That we will see in next video. But in this video, we will discover what basically AR model and MA model means. Then AR model is indicated by our ARP. Suppose if I am doing the forecast of July month using the data of June month and May month, then the value of P would be 2. Then the value of P would be 2. If I am forecasting the values using the values of past 2 intervals, then the P becomes 2. Now let's come to the MA. In MA, we do not use past actual values. We use past error terms. So if we continue the same example, I want to do the forecast for my July month. So YT still remains the same, forecasted values for the July month. But this time, I do not use the actual values. ET minus 1 is the error for your June month. ET minus 2 is error for your May month, and ET minus 3 is error for your April month. And this continues till now. And this C1, C2, C3, you can take it as slope. And again, if you notice, the equation looks something similar like your kind of linear equation. Only thing is we do not have a intercept part. We do not have an intercept part because we are using the error terms and not the actual values. And MA is denoted by your MAQ. Suppose if we are building the MA model and we are using only this much part, to predict, to do the forecasting, then the value of Q would be 2. Suppose if I am using for July month, if I am using June, May, and April, then the value of Q will become 3. Now comes to the third model, ARMA. ARMA, as the name suggests, it is nothing but your AR plus MA. So in ARMA model, we use previous actual values also and the previous error terms also. So ARMA is indicated by your ARMA, something like this, P comma Q. So over here, this P is mapped to your, this P is mapped to your AR, and this MA is mapped to your Q. Okay. So if you use past two actual values and last one error term, then the value of P would be 2 and the value of Q would be 1. ARIMA. So ARIMA is nothing but AR plus I plus MA. So we already understand what AR stands for. We already understand what MA stands for. Then only thing is your I. This I is mapped to your differencing. How many times you have done the differencing to make your series stationary? How many times you have done the differencing to make your series stationary? Suppose if your original data itself was stationary, then the value of D will become 0. If you have done your differencing once to make it stationary, then the value of D will become 1. And if you are doing the differencing 2 times, the value of D will become 2. And now let's discuss what is a SARIMA model. So in SARIMA model, if you notice, SARIMA consists of your ARIMA, and at the starting we have added S. So SARIMA model is used when your data is having seasonality. So if we go to the previous example over here in the air passenger data set, if you notice, the data was in uptrend and data was also seasonal. So seasonal means where the values rise and fall within a fixed time interval. So whenever your data is having a seasonality, and mark my words, I'm talking about seasonality and not stationarity. So when the data is seasonal, it is preferred that you use SARIMA because ARIMA cannot handle seasonality. If the data is seasonal, we have to use seasonality. Now let's come to the last one, which we have all in a way I've already discussed at the starting of the video itself. SARIMAX. So SARIMAX stands for your SARIMA plus X. So SARIMA X is used when your data is having seasonality effect also, and there is some external factor as well. So values rise and fall within a same time interval, within a fixed time interval. And then there are some external factors as well. So for example, let's say the number of people visiting a restaurant, or number of people visiting a shopping mall, or number of people visiting a cinema hall or a movie theater. Over there, we need to use SARIMA X because data would be seasonal, because in number of people visiting a restaurant or a movie hall or a shopping mall, the values will rise and fall on the weekly basis. The values may move towards, may go up towards on your weekends, and then they may fall towards your Monday and Tuesday. But it would also have some external factor. For example, let's say on Wednesday, that suddenly on Wednesday there is a holiday. Not every Wednesday would be a holiday. So that is an external factor which models cannot automatically take care of. So over there we have to use the SARIMA X model. So I think in this video we will stop over here. In my next video we will see, we'll open a Jupyter notebook and we will see how to code these models. And remember one thing, I'll give you the technical details also, how we can find the values of P and Q as well. So in next video, probably in next video, I will discuss what is correlation and what is autocorrelation, and how do we use these two to find the values of P and Q. So thank you again for watching this video.